Okay, so let's get started with the first official lecture for the weekend. It's going to be on expert systems. This particular lecture is called AI-Expert. It is available from the bhacker.com website. It's also available from the LMS. And it's everything you ever wanted to know about expert systems. Also gets into the concept of knowledge representation and knowledge databases and expert and production type systems. So this is going to be handy and very helpful for you in terms of your preparation for the final exam, because there is one question on the final that has to do with knowledge representation and expert systems. And so this is the purpose. Well, it's not only the purpose, but it's also, it will help you, but not the purpose for listening. The purpose for listening is to learn about artificial intelligence and expert systems. All right, so before I talk about all the good things about expert systems, let's talk about all the bad things, or all the weaknesses. And it's also important to know that expert systems also cross over into information systems as a concept. A lot of information systems fall into expert system categories. And going back to the title of this lecture, it was called Production or Expert Systems. I'll talk about the differences between those, but usually they're about the same these days. So most people talk about production systems that produce results, that that come and give you a solution to a problem, or they're used in production in the field or in some environment. And then we have this thing called the expert system. And it's kind of interesting because expert systems aren't really that intelligent. They're not experts. They're just taking somebody's knowledge and they're putting it into a database, or they're putting it into a system, and then they're replacing the need for an expert to actually be there. So expert systems, by example, are things like triage systems, accounting systems, your credit reporting systems, as an example. So that was an expert system. So when you, in the United States, when you go to apply for a loan, first thing I want to know is, well, how good is your credit? And they're going to, well, where did this credit concept come from? Well, you get a credit score. And there's actually 3 different credit scores that you can get from 3 different credit reporting companies that are using expert systems to come back and say, you're a 700, you're a 600, you're a 500, you're a 900. I don't even know what the scale is, but I know it's in hundreds. I know that part. But you should have like something, I don't know, 600 or 700. Maybe that's not a should. And then there's people with the 500s. The lower your score, the more... the less creditworthy you are. The higher the score, the more creditworthy you are. And apparently it's based upon, and this is an interesting question, what is it based upon? Well, how often you pay your bills, how many times you've declared bankruptcy, what do you own, how much do you owe, your assets, your credits, all that stuff. If you own a house, usually your credit score goes up a little bit. If you own a car, you have a car payment. Actually, believe it or not, it also is affected by if you've ever used credit. So those people who have never used credit, some international students who come to the States, they don't have credit cards, they don't have bank accounts. If you don't have anything, you got a real low credit score. It doesn't mean you have bad credit, it just means you're not part of the system yet, which is kind of interesting as well, which tells you that they're using an expert system. And the expert system's coming back, and an expert opinion is telling person A that they're creditworthy and person B that they're not creditworthy. And apparently, if you don't have credit, you're not creditworthy. Because we don't know. We can't trust you yet. Because we don't know how you're going to do well. So that's why a lot of people, in fact, that's why Citibank, I think, sits out here. Because you get a lot of people, you want to establish a bank account. You want to establish credit. That way you can actually earn a score. Until that, you can't buy anything. You can't use credit in this country unless you can't get credit unless you've used credit. So in other countries, they go, well, credit's bad because that means you're borrowing. It means you don't have money. But in the United States, it's the exact opposite. It promotes debt. Like, we're a country driven by debt. Which is, it sounds like a bad thing to say, but that's the reality of our economy. The United States is all about debt. The more debt we can get in, the better we're doing. Kind of seriously, because essentially it's a credit-driven environment. The more debt you're in, the higher your credit score, really. As long as you're paying back your debt. If you're not paying back your debt, you've got a really bad credit score at that point. All right, so now that we can kind of use it with credit as an example, the weaknesses of expert systems that you've been staring at requires a lot of detailed knowledge. You got to know what you're actually measuring and what knowledge is going into this measuring. So in order to build an expert system, we're going to have the knowledge. Yeah? Let's go. Okay, so the PPT is, you can't find it, huh? It is out on, let me open up a new window here. It should be listed in the Fall 2012 course. If it's not at the break, I can put it up there for you. I'm pretty sure that those are out in the lectures. Oh, you're right. It's not out here. It will be out here after the break. Unless you want me to do it now. Okay, at the break, we'll do it. I'll make sure I put it out there. Thank you for letting me know, actually. I thought it was out there. So back to the weaknesses. So you can look at, actually I'm only going to get through about half of it anyway. So at the break, get the rest of it, and you'll be able to download it if you don't like looking up there, which is kind of bright. Okay, so it requires expert knowledge and detailed knowledge. Also, there's a restricted knowledge domain. Credit reporting company doesn't really tell you about your car, your traffic, it doesn't really assess how well of a driver you are. Actually, it doesn't even assess how good the house is that you're buying that you're going to get credit for or anything like that. There's no knowledge of anything outside of the domain, so it's a restricted knowledge domain. Also, not all domain knowledge fits rule formats, so which is what the problem is. In fact, if you look at the concept of SAT scores, so in the United States, in order to go to college, in high school, you take what's called the SAT, or the PSATs, and in fact, you get this with college. You take a GRE, or you take a GMAT, or something, which are basically standardized tests that are expert systems that are telling you whether or not you're college worthy, but what are they really testing, and can you really put that into a rule-based test? If you answer this question correct, if you answer that question correct, are you really able to do well in graduate school? So sometimes it doesn't really fit well. In fact, the big thing in the States is, SATs are supposed to be biased towards different cultures. And, for the longest time they were saying, well, girls don't score as well in it because it's all the questions are made for boys. It's like, wait a minute now. It's like, anyway, so there's a lot of controversy usually with these types of tests. In fact, they find that the international students don't score well on GMAT tests because a lot of the logic is cultural based. So anyway, long story short, that's another one of the biases. Not to say anything is true or false, but expert consensus must also exist, which, going back to, I can't really tell you if it's true or false because there's no consensus among a lot of people in terms of, are the tests real, is the credit score real? In fact, because there's no consensus, we have 3 different credit reporting companies, and each one of them has a different opinion on your creditworthiness. In fact, one company doesn't even consider whether you're employed or not. Another company is based solely on what your current income is, really. If you have the money, they think you're creditworthy. So there's differences among the credit reporting companies. Also, knowledge acquisition is time-consuming. How many years it took them to come up with this credit score concept? Many years, many knowledge-consuming years. And truth maintenance is hard to maintain. What does that mean? Well, the validity or the truthness of the response that's coming out of that is really hard to actually retain. And then forgetting bad facts is hard, especially if you've got shifts in the data, shifts in the knowledge. It's hard to actually weed out bad facts out of the knowledge base. As an example, if we said, the credit reporting companies were interested in looking at, as an example, how long you've been employed. Well, there's one company in general who doesn't look at that because the shifts in certain careers, there's low employment, they're not at the same job. So in the old days, a bad fact would be, how long have you been at your job? If you've been at your job for 20 years, your credit score would go up. But that means you're stagnant in your career, and maybe you're doing a manual labor job and you haven't grown at all. And then someone who is like, a CEO who leaves a company, who goes to another company, who goes to another company, really high-paying job, really nice job, but they're not there for that long. They're only there for like 6 months to a year, or 2 years, or 3 years at the most. They're going to get a lousy credit score based on that system. So that would be a bad fact that you had in there, and you'd have to somehow forget that. Well, then you have to overwrite that fact with new facts that would say, well, if you're a CEO, then it's okay not to be there for 20 years. Personally, right now in America, you don't want to be on a job for 20 years. If you are, you're probably not getting paid enough because in order to get a higher salary nowadays, you have to quit your job and find another job, because that's the only way they give you a raise these days, because cost of living never gets in, they're supposed to give you a cost of living increase and stuff, and they're supposed to, but that's kind of like the typical problem right now. It's like there's no consistency among different companies, there's no fairness in the system. So in order to get fair, you leave, you leave and you go into another company. That means you're making more money, you're doing more for your career. So, but that's wrong with one of these credit card companies. So anyway, and I'm not giving you an entire survey on how to beat the credit card company system, but it's just an example. When I'm talking about are rule-based systems, that's one category. One category of the expert system is a rule-based system. And so the rule-based system is also known as the production system, also known as the expert system. So these are all different terms that are all used to describe the same concept. Rule-based systems are one in which are most successful AI examples. So credit card company system, very successful system. It's an AI application. So most of the ones we hear about in the news that people go, oh, this is a good one, it's rule-based, and it's an expert system kind of system. A lot of people don't like AI. They don't want to use that term. They don't want to use expert system, which is really the AI terminology for it. So they'll call it a rule-based system. Used for also synthesis or construction type systems. How do you construct a purchase order? How do you construct a sales receipt? How do you construct an inventory parts list or something? You use a rule-based system. And it's artificial intelligence, actually. It's a category of artificial intelligence. So you took a CAD drawing, and you put it into the system, and you asked the rule-based system or the expert system, give me a parts list. So it's going to go through and count up how many of this piece and how many of that piece. Hopefully you have just some consistent pieces in this drawing. And come up with a list, and then match that with the supply chain management system, and then come up with a cost. And then put that in through a production schedule, and integrate it with your ERP system, and then you can come out with, as an example, an expert system where you can take a CAD drawing and it'll tell you how much it will cost to make the product in batches 100, how much will it cost to make it in batches 200, 300, or 1,000. So how many you can make to optimize your production schedule. So supply chain management people are interested in this type of application so that they can minimize their costs and ordering quantity. Production manufacturing people can use expert systems all the time to adjust production schedules. Because if you run the run, if you're working in a manufacturing plant, you're using an expert system to do your scheduling. Because what ends up happening is you're not going to manually come up with all these different schedules, all the different sub-assemblies, all the different people you need. Because you got equipment, you got manpower, you got building, you got overhead expenses, you got parts and the delivery of parts that you're going to need. You got the flow, how this thing's going to be built to work with. You can't manually do it like in the old days, so too complicated. So you use an expert system, you plug all this stuff in there, and it tells you you need to hire 5 people. And it tells you you have to run this for 8 hours today. And it tells you how many pieces are actually going to come off that line at the end of 8 hours. So the expert is telling the human what to do, essentially, which is where that terminology kind of comes into place. So for construction, this construction is referring to the synthesis, or it's referring to what the example I just told you with production schedules in a production plant. So this is going back to a production system. This is from the terminology used in operations or in manufacturing management. In production schedules, assembly schedules and stuff, which is where that's coming from. Also used for analysis, diagnostics and classifications type systems. Classic example is what a doctor does. So the doctor is the expert. So what does an expert do? In terms of artificial intelligence, it thinks. How does it think? Well, it does analysis. So you go to school and you learn a bunch of facts. And you learn about the neurologist, the neural system, and you learn about the, I don't know all the I'm not a doctor, I don't know all the subsystems. Well, I have a PhD, but I'm not a medical doctor, so I don't know about all the different subsystems of the body. But if I did, and if I were a medical doctor, and a patient came to me and said, hey, I got a pain in my side. First thing I'm going to think about is, well, what organs are on your side? And I'm going to go through my database in my head, and I'm going to go, well, we got to this organ, we got to that organ. And then the doctor's going to ask you a question. Well, where exactly is the pain? And then you'll figure out, well, what organ is likely to be in that area? And then the doctor's going to come back and say, well, how long have you had the pain? And depending upon how long they've had the pain, there's going to be a piece of information back in the back of the mind of the medical doctor who's going to say, well, if they've had it for prolonged, then it's this category of pain. If it's a sharp pain and they haven't had it for too long, it's going to fall into this category. And they're doing a classification, and it's a way of solving the problem using classification. They're going to put you in a certain class. And then once they have figured out that it's a sharp pain, okay, then they're going to tell you, well, how often does it happen? You know, they're going to get all the facts by doing a question-answer interview with you. And then they're going to get, okay, hey, wait right here. And then you're thinking as a patient, well, I haven't told you about this, and I haven't told you about that, and all this other stuff, right? They don't need to know anything about that. All they need to know is the answers to the questions they asked you. Then they go in the back room, and they think about it, and they go, maybe consult with another doctor, and then they come back and say, ask you another question. Have you eaten recently at Chow's famous Chinese food restaurant? And you're going to say, yeah, I just ate there last night. And then they're going to come back and say, well, you have food poisoning. Or, you know, or they're going to say, you know, oh, you have E. coli poisoning or something. Or, you know, depending, and this is basically what they're going to do. Or they're going to say, well, you say, no, I haven't eaten there. Well, have you eaten a lot lately? You know, we think it's your stomach. And then they start telling you. And then they'll ask for more information from you, which is kind of like how the interview works. So you can do the same scenario in a computer program. So you have a medical, let's say you're one of these local hospitals, and this is basically how the local hospitals are running. You have what's called a triage information system that sits at the counter. So the patient walks into the medical room, and the trained professional who is sitting behind the computer is not a medical doctor, not a nurse, not even trained in anything having to do with hospitals. In fact, the person probably has a high school diploma, I hope, and is making minimum wage perhaps, who knows, not being paid that much, but is a computer operator. They have operator skills. Or maybe they know how to take blood pressure and temperature, which hopefully they're trained to do that. So they fill out a form on the expert system, and the form says usually, what's your name? You know, you're walking into the emergency room. What's your name? How old are you? Okay, why are you here today? They type this stuff into the computer, into a form, where it's asking them for input, and then they press, okay, go to the next screen. And it's going to say, well, depending upon what you typed in, it's going to read it, and it's going to analyze it and say, okay, take the person's temperature. Okay, here, hold on. And maybe some of this stuff is routine. Maybe they just do it anyway. They put the temperature in, they put the blood pressure in, or whatever it is they're taking. And then it comes back again with another prompt. It says, hey, ask the patient if they feel dizzy. Oh, okay, so then you ask, do you feel dizzy? And then the person goes, yeah, I feel dizzy. Okay, okay. And then they usually say, oh, okay, on a scale of 1 to 10, because they have to put a number in the form, how dizzy do you feel? 10. Okay, you put the 10 in. This is an expert system, by the way. And so it comes back and says, and then anyway, this system is already, as you're putting the information in, is already telling the rest of the hospital that you've got a patient who's coming in who has a headache, you know, or they have chest pain, or they have, or the classic example of the system, you know, they're bleeding. Are you bleeding on the floor? And sometimes they'll look out because they have to answer a question. Yes, bleeding on the floor, you know. And this then goes back in, and then it says, an answer comes back out of this rule-based system that says, put a blue band, put a red band, put a yellow band, whatever the color coding system is on the patient. Okay. And then, or send the patient to section A, section B. So you get prioritized, you get categorized by what you're telling the person. So naturally, if you want to be seen immediately, you always have chest pain. But then they're going to be upset when you come in because you're wasting their time if you don't have chest pain. They're wasting your time, essentially, because they're going to ask you other weeding questions. It's going to see if you're trying to waste their time or whether or not you're actually really critical or not. So it looks like this. Here's the rule format where we have a condition, then an action, then an action. What I just described to you is an interactive expert system that falls into the information systems categories that I've alluded to before, where we get feedback and then we ask more questions, and we get feedback, and then we ask more questions. So it's interpreting in a real-time fashion. There's other systems that don't do that, like the credit card company. You just fill out an application form. You give them the information they want, they come back and tell you 700. No chances to explain anything. So that's not an interactive system. That's, again, another example of an expert system, but they're just going to tell you what your score is. So they come in different forms. The generic system components are here. We usually have a global database of some sort. Also talking about the concept of working memory. Not really a database, not like an Oracle database. It's the working memory. It's what is your blood pressure? What's your pulse? Are you bleeding on the floor? You're not bleeding on the floor? You know, all of the different things. That's the working memory. We have the production rules, which is the knowledge base of the system. Those are the questions, or those are the rules. So the questions provide the input to the rules. The rules are applied in an if-then kind of fashion. This is what Prolog is really good for. Lisp is good for list processing. Scheme is good for recursive function processing. Prolog is good for logic and rule-based systems. So you can make a really nice expert system using Prolog. And then after we have the rules, the production rules, then we have the Inference Engine. And the Inference Engine is the interpreter. So you run the interpreter and control the subsystem via the information that's coming in. And this one here is a nice little sophisticated human tutor. It's an expert or knowledge engineer who's doing the same thing as the computer is doing. So the first thing you do is you do this. You sketch out the expert system architecture, and then you build it in a computer program. And then you stick it in front of a person who's trained to operate it. And then you have an expert, which is how the pieces come together. Why do you want to do that? So you don't have to hire a bunch of medical doctors to do triage. You don't actually have to hire a bunch of people who are trained in credit card systems or reporting and all that stuff to give you a score to approve or disapprove your credit score. Those people are doing nothing. They're just filling out forms. Not to do, not to downgrade their jobs. They have good jobs, but they're not really thinking. They're not the ones telling you if you can get a car loan or not. They're just reporting back what they're getting from the expert, and the expert is the information that they're being processed through. So here we have the expert system, then we have the natural language interpreter perhaps. So let's talk about Siri for a second. Siri comes in with a natural language processor that's part of this expert system, which is kind of the least critical kind of component of it. She's just doing, how many Chinese food restaurants are in Santa Clara? And then it's taking that and going, la, 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 whatever the computer does. It comes in and translates it into text, puts it into a search. And then it kind of comes up here into the inference engine or the reasoner who says, oh, this dumb person wants to know about Chinese food restaurants in Santa Clara County. Okay, no problem, we'll do this for it. It goes down to the workspace and it says, okay, here's the problem description. We need to find the Chinese restaurants that are in Santa Clara. Problem status, okay, not solved yet. Oh, let's solve it. So we go over here to the knowledge acquisition system. Oh, let's just use the internet. So it goes out and kind of says, okay, Chinese food, okay. Oh, look at that, there's 50 of them, okay. So then it comes back and checks against the facts and goes, well, are these 50, are they really Chinese food restaurants? Or no, actually one of them's Asian Chinese. 49, we got 49 now. We got rid of that one. Okay, what about get rid of that one too, 48. And then we have the inference and the rules that we go through, to check to make sure each one of them is really a Chinese food restaurant. So, okay, we got 46 came out of here. We go back to the inference engine or the reasoner and says, okay, we've deduced that 46 of these are really Chinese restaurants. And we go back to the explanation system, and we go back to the natural language interpreter, and we go back to the user and say, there are 46 restaurants in Santa Clara County. So Siri's an expert system. She's an expert. She's running as an AI expert system. And that's what she's doing in terms of her logic. So if you're going to design a Siri component for your mobile app or your device, then you're going to look at the architecture this way. In this particular case, I'm not saying that's exactly what she's doing. She's got a little bit more stuff going on inside of her brain, but in essence, in a nutshell, she could be described this way in terms of her architecture. But that may not necessarily be exactly what she's doing. So, not to give you the impression that it is as simple as that. It's actually more complicated because the natural language processing on the inference engine, if you said, Siri, will you marry me? Or Siri, are you married? It'll come back and say, oh, the reasoner is going to say, this isn't something I can look up on the internet. Wait a minute now. The person's asked me for a joke, or the person asked me this ridiculous question, then it may not make it out this far. The inference engine is going to say, okay, weird question. Okay, come back out here and tell the user, well, I don't know, you're not my type. Or it's going to come back with something it's trained to do, given the inference engine. It's going to come back and say, no, I'm not married. Or, yes, I'm married to Apple, or something, or to somebody, you know. Anyway, that's how the inference engine works. It's different than a knowledge lookup. So Siri is not an internet search engine. She's inferencing. She's inferring what you're saying. She's using a knowledge base with an inference engine to derive at a conclusion to give you a logical answer given her expertise. Her expertise is what the programmer put into her program. So, forward chaining procedure. We have forward and we have backward chaining to work with. And we talked about this last time, but it's not a bad concept to review in terms of the concept. You do until a problem is solved or no antecedents match. You don't get a match. So, forward chaining, you start with Siri, are there restaurants in Santa Clara County that serve Chinese food? And she goes and she comes back and says, I'm sorry, there aren't any restaurants here. Because she searched through every single possible restaurant that was available, and none of them were served Chinese food. So you can collect the rules through the antecedents that are found, and the rules are found in the working memory or in the database. If no rules match, then use a conflict resolution strategy to eliminate all but one of them. Which means you might come back and say, well, find me the best Chinese food restaurant in Santa Clara County. The best one? Okay, and she comes back and says, well, there's two of them here, but you want the best one. Then it has to use conflict resolution in its rule base to know which one's going to be the better one. So it might, if Siri was intelligent, she'd come back, and I don't think she does this, come back and say, what's your criteria for best? Then, because she's not going to be able to decide to do the conflict resolution between the two that came up or the three that came up. Give me the best student in this class. Well, that depends on your definition of best. One that scores the highest? Not necessarily the best. Maybe that student cheated. That would be like the worst student in the class or something. So do actions to indicate that are indicated by the rule fired. So here's how the inference engine is designed, where we have a rule base, and then we can find matches in the rules, and we can execute new rules, add new facts to the fact base. And then the conflict resolution is what I was describing before in terms of conflict resolution, is going back to the hospital triage system where the person came up and now this is a situation where they have a pain in their side, and you went over and you said, you know, did you have Chinese food? I cannot keep harping on Chinese food right now. Okay, so did you have Italian food? And then the patient comes back and says, well, no, I didn't have Italian food. Oh, okay. And then comes back and says, well, did you have Vietnamese food? He says, yes, I had Vietnamese food. And there's 3 Vietnamese restaurants, let's say, that have had reports of E. coli poisoning or something that's in the database, and we know about this information already. Then it's going to come back and say, well, did you eat at a restaurant? And it's trying to do the conflict resolution by getting more information, which is what happens with credit card reporting companies. It'll come back and say, decline, but it's because we're missing this piece of information. Where did you work? Where did you live at the last place you lived? You didn't put it in the form. We only have your last residence, and you've only been at your last residence for 6 months, and we have no previous residence information for you. So to do the conflict resolution, one of the strategies is to be more specific and say, okay, where did you actually live before this address? And then you provide it with more information, just like providing, well, where did you eat the Vietnamese food? And then it can resolve the conflict by the additional piece of information, just like Siri asking, you know, what do you mean by best, kind of thing. So we have conflict resolution strategies that you build into the expert system to make this more robust. We have specificity or maximum specificity. Let's just say specific. You want to be more specific with this. You want to add more information based on the number of antecedent matches perhaps, or based, you choose the one with the most matches that are associated with it. So what one, if I were to pick the best Chinese food restaurant, I'd probably pick the one with the best ratings, plus the best attendance rate, plus the longest in business, plus all of these other things. If there were more rules that were matching that led me to this one versus this one over here that wasn't around too long, that maybe had the best food, had the best ratings as well, but maybe they were missing something else, then this one over here would win, kind of thing. You can also use the physical ordering of the rules and the criteria. That one is skeptical. Hard to add rules to these systems. So you come back and say, well, this system always comes back and it finds these two. Well, one of them's better. Then you implement another rule. You put a rule in there so it only comes back with one. Then what are you doing? You're fixing the SAT scores so that only white kids get enrolled in college and all of the minority kids don't, because you're asking questions about white things, culture for white people or for Americans, that other nationalities aren't going to be able to answer correctly. So then you're biasing the system, which is what you're doing when you physically order the rules, or you add rules in a different order, so you apply the rules on top of the other rules, and then all of a sudden people complain about your system because, hey, it's biased, or the rules don't make sense, or the order of the rules are wrong. Which is kind of interesting because the physical order of the rules will weed out possible selections automatically. So if you failed the first rule, you're not going to make it past. You're not going to end up in the search results. You're not going to end up anywhere because you were knocked out on the first round. Also, data ordering. How are you going to order the data? Which ones are going to come up first in the system? If I were to say, you know, give me the best student in this class, well, if I took you by alphabetical order, I might find a different student if I went reverse order versus alphabetical order. Because I'm going to find the best student, I'm going to find the first best student in the class that comes out of here because I just want one. This is what search engine results do to you, which is why people pay to be higher up on the search engine results. You're not going to look too much farther. Once you find one that works, give me a good student. All right, I'm going to go through the list starting with the A's, B's. Oh, here's one. If I took the opposite order of the list, I'm going to find a different student. If I just want a good, give me one good student, I'm going to find a different student depending upon which way. Same thing happens with search results. You know, if you're not in the first 10, first 20, you're never going to be seen by anybody. If your company always shows up like after 10, after 15, 20, the user's going to, when you do search results, you look at the first couple of them. Actually, I never look at the first one. I always go to a second or third because my eyes naturally go to the middle of the page, which statistically it's proven the second or third is more popular than the first one that comes out because people aren't going to look at the top. So it depends on how far that you scroll down. Naturally, you're just going to go, okay, let's go down the list because you want to be fair. You're going to go down the list. You're going to hit the middle of the page, which is number 2 or 3, which is better than being number 1, actually. For clicks. So you click on that and you go, oh, okay, that was my problem. I'm not going to look any further. I have my answer to my question. I don't have to look any further. So that's going to be the ordering, the data ordering that's going to determine which problem you're going to find. Also, recency. How recent did you do the ordering? In terms of the data, it's based on the order of facts that are added and the rules based on the rule findings. So if I asked you when you first walked into the medical triage center, as I said, first question I asked you was, did you have Chinese food? And you said, yeah. As a matter of fact, I had Chinese food. Then I asked you if you had a site, where is your pain? And you said, oh, it's in my left arm. Well, that's not even associated with Chinese food. So the order that I asked you that rule in is going to give me the wrong result because I'm going to say, oh, you have E. coli poisoning. Yeah, you had Chinese food. You made it at home. You know, you ate at Chow's. You had all the other things that the E. coli poisoning patients had. But you don't have a stomach ache because you have an arm ache because you twisted your arm and you need someone to like look at your arm to see if it's broken, which is why you came to the emergency room. So in that particular case, the recency and the ordering for which you have obtained the rules and you're applying the rules is completely wrong for the solution. So a lot of thought has to actually go into that in order to do conflict resolution. Because if it comes back and says, well, you either have a sprained ankle, a sprained arm, or E. coli poisoning. Conflict resolution, we're looking at and go, oh, hopefully you'd be able to determine it's an arm and not a sprained ankle or not E. coli poisoning. So, conflict resolution strategies, here we go. Context limiting, that's what I've been talking about actually. Let's change the context. If you're complaining about your arm, most likely you don't have food poisoning. Most likely you don't have a twisted ankle either. This is interesting, it just got dark. I wonder why. Did we just lose lights somewhere? Oh, now we got lights. Where are they coming from though? The lights went off and then the lights went back on, but look over here. No one's over there touching the switches. Is it Halloween again? Scary. In the context, if I were to move this last experience, if I were to put it into artificial intelligence, it has to come out with something odd, because in the context of that problem happening, it had nothing to do with the light switches. So either we're going to lose our power and get to go home early today, which I've never experienced at ITU, or in that context, I can't tell you what happened. But if we're going back to expert system, partitioning the rule base into disjunct subsets, you know, as an example, solving the problem to figure out that you have a twisted ankle, perhaps. I'm not going to look at arms, I'm not going to look at stomachs, I'm just going to look at ankle problems. I'm just going to look at stomach problems if I'm trying to diagnose food poisoning or whatever happens to be wrong with the stomach. If it is the stomach, it may not be the stomach. So doing this, we can have subsets that we want to have for preconditions, so we can limit the context, we can conflict resolve a little bit more accurately. Also the execution time. How fast did it come back with this solution? So if you put something in a search engine and it comes back quickly, you know that the search was probably good. And you know that actually everything comes back quickly, but in the old days it used to take longer. Like when the first search engines were out, you put something in there and you waited. If it took too long for the results to come back, most likely they're bad results. So if the expert engine takes too long to come back and say, well, here it comes. We think you have a stomachache. It's going to be we think instead of instantly you have a stomachache. Oh. So it's actually the same thing with people. In fact, the same thing happens with a real doctor. You know, usually if the doctor comes back instantly and says, you have E. coli poisoning, they're pretty sure you do. The answer is more reliable. It is correct. If it comes back after several hours of exploration and research and diagnostic and further questions, and this goes on for a couple of days, and then they calls you up on the phone and he says, well, we sort of think you had E. coli poisoning. Not as definite. Probably the wrong answer, actually. So the time and execution, in terms of the working of your system, you're going to have execution various times because you're working with a computer program who's doing a search. So if Siri takes longer to come back, her answer is not as good as if she comes back instantly, because the instant response is more reliable. So it's kind of like human thinking, actually. And I always say this, and people always disagree with me on this, but always trust your first instinct. If you think something's wrong, it is wrong. Instantly. If you immediately come back and say, oh, that's not right, it's not right. If you sit there and deliberate on it for too long, you're going to convince yourself and you're going to confuse yourself. So when you're answering a test, always answer with your first instinct and don't change it. It's the students who like erase it. We'll go with this one. Erase it. Oh no, let's go with that one. You will take a good answer and you'll make it wrong because you'll add too many things into it and you'll spend longer. Longer thinking, longer analysis produces worse results. And it's true with expert systems. The longer the expert system takes, the more unreliable the results are in general, because it's deliberating. It's doing conflict resolution. It's doing all this stuff. It's not coming out with a direct answer. And your first instinct always gives you the best answer. So. And they prove it's not just my BS. They've actually proven it. There's statistical studies that show in terms of test-taking behavior. You read it, one of them is going to point out that one's the correct answer. The first one, if you're doing multiple choice, the first one you see without thinking is the correct answer. If it's an advanced test, however, you need to read the other answers because it might be a trick of the test maker who's tricking you because they're going to see which people are actually going to read the question correctly, because you may have misread the question. Then you only look at the question again to make sure that it's not a trick, and it is the right answer. And then that's where people run into problems, because then the inexperienced test taker will get tricked by the trick, and then they'll get fooled by the bait that's placed in the question. And then they'll go, oh, wait a minute now, but this is also true, and this one's also true. And then after you look at it long enough, if you spend too much time looking at it, they're all true. They're all false. They all apply. Not so good. So that's kind of interesting part. And I don't know why IT students love to take multiple choice tests, because you guys will score worse on a multiple choice test than you would if I gave you a short answer test. Because you're going to fall for every single one of the tricks. In fact, on that database class, you guys fell for most of the tricks. I've already looked at it and I went, oh my God. How could they fall for that? The cross join is a multiple. You're actually supposed to times them together, actually. And hardly anyone times them on the cross join. But if you ever in the database class, you know what I'm talking about, that question. It said this one crossed this one. It's this one times this one. Some people did get that one right. With the multiple choice ones, commonly missed. The more difficult ones, perfect. Those entity relationship diagrams, the table look good. It's just those multiple choices that you missed. But people want multiple choice. This is kind of ironic. So let me talk about another example here of an expert system called the bagger. So you go to the grocery store and they want to put your items into bags. So you can come up with an expert system that will determine which items should go in which bags. So this is the bagger expert system. So it bags groceries for you. So it checks the order to see if the customer has forgotten something first. So this is the order in which the rules are going to be fired and the order in which the system is going to be designed to optimize the bagging process. So it checks the order to see if the customers have forgotten something. And then you bag the large items with special attention to the bagging big bottles first. And then we're going to do the bag medium items with special attention to the frozen foods. And then we're going to get the small bags, putting everything in a small room that we have left for bagging small items, putting it in the rest. So if you ever noticed, if you ever watch people bag, of course people don't bag things anymore because now we don't have bags. You know, they don't give us bags, so we bring our own bag and we bag it ourselves, which causes many problems. But if you ever notice, they bring out a big bag and they put like the soda bottles in the big bag, and then they'll bring out another bag when they go, oh, I'm going to need more than one. And they'll start selecting which items go into which one. And then they wait till the end. They put the small stuff in the tops of all the bags and just fill up whatever's left, which is how you're supposed to be, you know, if you're doing grocery store bagging. I've never done this for a living, so I have no idea. But anyway, you have a set of rules. And you see the rules. So the bagger, there would be a set of rules. See the handout. Well, okay, so the manager would give the bagger a handout, and the handout would have all the rules on it. That's how you're supposed to bag stuff. Then you have to do conflict resolution. So, because occasionally you're going to have two items that are the same size. What bag are you going to stick them in? Or you're not going to have any small items. So does that mean you need 5 bags, but there's no small items? So you have to do the conflict resolution. So you can have a couple choices with this in terms of this problem scenario. Maximum specificity, so it can be simulated by careful rule ordering. Or context limiting, it needs to be set and evaluate the context variable. Well, we're probably going to use a context limiting one. We're going to look at what we have. We're going to look at what we have to put in the bags. And we're going to have to sort of figure out, well, all right, so let's limit the context. How many big items do we have? If we go through the rule base, this is the rule for bag number 1, the rule for bag number 2, the rule for bag number 3. I'm not going to bore you with the semantics of all of the bags and all of the rules for the bags. But what kind of concept you want to get out of this is sort of the process. So if there's something, then there's something. If there's something, then there's something. If there's something, then there's something. So the if-then format is used in the rule base, which is what Prolog does for you automatically. If you don't use a program like Prolog, then you're writing your own set of if-then statements. And you're going to do it in C or C++, or you're going to do it in Java or something. Then you're using control flow. You're using constructs that are going to determine the flow. If something, then something, if something, then something, yada yada, continues onward. So the working memory would have bag number 1. This would be a medium, this would be a small, this would be a large. Oh, there's 2 larges, a medium, or you know. This is the size bag that it's going to go into. And you're going to determine based on the role base which bag you're going to stick something in. If you think about the concept, this is how humans reason. So if you're going to pick up a bunch of stuff to carry it, you're going to pick it up in an order that's determined so that you can carry it to maximize the goal. So bag of rule firing order is determined, so we can choose here, choose here, choose here, choose here. And you know, this is basically just the sample output for the bagging order. So the process that you would go through. Unlucky for you, I don't ask you on the final to go through an expert system, so you don't have to really do this, but if you were to build one, this is what you would go through, essentially. And then you'd go through the scenarios, and then you'd test it. So after you did this and you did the analysis, this would be the research and the analysis part of it, where you'd come through the rules, design the process, test it to see if it actually works, look at the bag output, look at the conflict resolution, and then it works. Great. So put it in a computer program, and actually they do this for some fast food places. It tells you what order with pictures. You know, do this first, do that second, you know, and you can have like memory aids. You can look at the pictures. Actually, you probably have seen it with public restrooms with, you know, wash your hands before leaving, and you see the water coming out, and you see the hands, and you see the person leaving the restroom. It's like those are the rules that you're supposed to do before you leave the restroom. And you think, well, this is for stupid people. And then you go, well, how many people don't wash their hands? You look at that, and you can just watch people, and they don't do it. If they see the sign, there's higher likelihood of them actually doing it, because they go, oh, maybe I should wash my hands, okay. You know, especially if it's a restaurant and they're working and they're preparing your food, you might be concerned with that, actually. So I usually have this before lunch, and people go, oh, E. coli poisoning, and people who don't wash their hands before going to lunch, or before going to go prepare your food. Great. Lovely thoughts. Here's another one, actually, that used in a more computer science area. Looking at a rule-based system for developing used by DEC for developing and configuring VAX computers. One of these VAX. Okay, think of these as special mainframe computers that are built for companies. Company goes to DEC and says, hey, I want this computer system. I mean, we need this server. It needs to have this processor. It has to have this much memory. It's got to have these ports on it. So you're customizing the build. So they're going to want, you know, input is the customer order. What do you want? And then it has to build it for you. And so let's say this is really customized, and it's actually building the board, and it's doing all the soldering. It's giving you all the layout for the diagrams of the wiring and all of the components. So the output is the corrected order with the diagrams showing the component layouts and the wiring and the suggestions. And then it does in minutes what used to take humans days and much longer to do in terms of an error rate. Actually, there's some PCB manufacturing companies that work with these expert systems, and there's some programs that you can do for design, VSLI designs and stuff, where it will tell you, given all these components and the space that you have available, here's how you should wire it. And what does it do? Well, it's an expert system because it's taking the knowledge of the power requirements, the feed requirements, all of the little details that go into the design of the wiring. And you don't have to know anything about the design of wiring of PCB boards to kind of conceptualize this concept. But there's a lot of stuff that goes into factors. You can't put this too close to that. There's going to be interference, and this is going to have a heat. This is going to put off heat. We need ventilation. We need air. We need this. We need that. And this has to be a certain thickness so we don't get interference, and all this other stuff that goes into this thing. Well, the expert system can tell you everything, and it just spits out, here's the design. Okay, make that. Oh, okay, good. So the human doesn't have to think anymore, kind of thing. Well, sort of CAD systems sort of do that too for you automatically as well. When they give you parts lists, give you better designs, like this. This design could be improved for this. So I need to make this smaller. Tell me how to make this smaller. Or I want to put this in 2 layers instead of 1 layer, 3 layers, 4 layers. You know, I want to reduce the layers. Okay, it'll give you alternative design suggestions, and it's the expert system engine that's doing that for you. So usually around this point in time, people go, well, what's an expert system? Everything sounds like an expert system. Well, there's a fine line between what's considered an expert system and what's not. Something that does a predictable response that any human can do on average, not an expert system. A system that's replacing the need for a trained expert, and that's a subjective term because we don't know what a trained expert would be. It's context-oriented. That would be an expert system. So a computer technician being able to troubleshoot a problem, well, that would be sort of an expert system. So think about the modern day cars. In the old days, people said, you know, after 3,000 miles, you're supposed to change your oil. You know, actually 3,000 or 5,000. I don't know, there's all these rules are out there that people used to follow. And now the cars tell you. But is it an expert system, or is it using the mileage? So you can have a car that tells you that you need to change your oil based on the number of miles you've driven. Well, that's the same as putting a sticker up there from Jiffy Lube or something, you know, it says, hey, change your oil after this number of miles. Not an expert system. Not one at all. But then you got the car that has the expert system in it that isn't going to use mileage. Instead, it's going to test your oil for you. Every couple of miles or so, it just tests, you know, what's in this oil? Is there dirt in the oil? Is it thin? Is it, you know, what octane is this? It'll do a chemical analysis of it, and maybe one time you can drive your car 3,000 miles and it's fine. And then maybe one time you want to drive it 100 miles, and it says, hey, you know what? You need to change your oil. Or 2,000 miles, or it varies the time because it's using more of an expert analysis. Because sometimes you go in after 3,000 miles, there's no need to change your oil. In fact, people used to use time, and the old non-synthetic oils used to age. And you know, after about 2 months or what was it? I think it was Jiffy Lube that was doing it. 3 months or 3,000 miles, you need to get your oil changed. But your car was sitting in the garage for 6 months. But you put synthetic oil in there, though. If you test that oil, some mechanic would not change it. Go, oh, there's nothing wrong with this oil. Oil's perfect. But it's the oil. Maybe it's the quality, the brand, I don't know. Maybe it's how tight the seals are and how preserved the oil is and hasn't degraded as much because it hasn't had as much exposure to air or to water or something, whatever happens to be a contaminant for the oil, medical particles or something. Which is why when they say you get a brand new car, with an automatic transmission, you're supposed to change your oil after 300. The transmission fluid needs to be changed like after 3,000 miles or so. When the first transmission change isn't really until about 10,000 miles or so, because you get rust particles, or excuse me, metal particles from the fittings that wear. So when the transmission breaks in, this is older cars by the way, when the transmission breaks in the old days, it used to put contaminants into the transmission fluid that sat there and deteriorated the quality of your transmission for the first 10,000 miles. But after that, you don't have to change it because it doesn't have any more of those particles anymore. Anyway, long story short, what I'm saying is if you actually had, and the cars do this now, actually had an expert system electronic tester. Let's test the fluid. Let's do an analysis on it. Run it through a bunch of if-then statements, and then it says, servicing. You should service your car. So some people, actually my Fiat does this. I have to service more often. I'm not getting the full life because I'm doing a lot of in-town. I do a lot of miles on that car. So, and the type of driving that I do forces it to get serviced more often, actually. And then my service advisor was actually telling me this the other day because I do a lot of in-town driving. Constantly short stops, turn on and off. I don't drive for more than like 10 or 15 minutes at a time. If I take it out on the freeway and I run it for like miles, take it to LA and back, I'm not going to have to change the oil as often. Nor will I have to do any of the other servicing that I have to do on it because I'm doing stop-and-go traffic. Same thing with your brakes, actually. My brakes are going to have to be replaced a lot faster than if I were to drive it to LA and back, which is kind of the same thing with every car out there, actually. So, long story short, an artificially intelligent expert system can tell me that that's an expert system. One that just says, hey, you've owned the car for 2 months. You need the oil changed. Not an expert. Not right. Not normally right. So expert systems produce more accurate results normally, correct answers, and not waste of money answers, like what the car people try to tell you. Okay, so here's another example, R1 XCON system, similar to the bagger. This is a forward chaining technique. So forward chaining starts out at the beginning and tries the rules. Makes use of the maximum specificity and the context limiting conflict resolution strategies. And the rules are written in this particular case, OPS5, which is a rule-based language system. So this is an example of a language system that was developed by this particular company to create this solution to the problem. I'm not going to go through the problem solution, but just know that this was a proprietary language that was used. So a lot of these expert systems are proprietary based, or they're on open source. But here's the trick. So Siri's, you're never going to know exactly what her expert system is doing, because they're not going to release that. They're not going to tell you what that algorithm is. Otherwise, everybody's going to have a Siri's algorithm out there. There's no competition with that, right? So you're building a credit card reporting company system. Are you really going to tell the people? You're going to tell the general public why your score is your certain way? No. Because if you do that, then everyone will have a perfect score. It's kind of like if I gave you the answers to the test, would you get an A on it? Hopefully you would. If you didn't, there's something wrong with your study habits. So a lot of this stuff isn't known, so you're not going to use open source utilities for this. If you're a company doing this, you're going to develop your own system for it. There's stages in here. I'm going to kind of skip through this because this one's kind of boring. But if you go through stages to develop this system, you're going to check the order for missing parts and pieces and layout of the cabinets and the pieces and the components and the floor plan and stuff. So you're going to come up with a bunch of rules just like before. And then you have this answering questions kind of thing. So most expert system users insist on being able to request an explanation for how the expert system reached its results. That's when you go back and say, how come I got a bad score on my credit report? How come this one says it's a 600 and this one says it's a 700 or 800? Whatever that score means. That's when the explanation comes back. That's when you give away the secret of the expert system, which you're not going to get too much information at credit card reporting companies. The only thing you're going to hear is one of them puts a higher focus on how long you've been at your job. It depends upon the type of career you're in terms of whether or not you're going to score well with that company. Another one looks at how much debt do you have. The bigger your amount of debt, I believe this is Asperian, but don't quote me on this, the more you're in debt, the more amount you owe, but you've been consistent paying it back, the more credit you're going to get. They'll give you a $100,000 credit limit on your credit card because you're going to spend it, hopefully. But you're a good risk because you've had a $100,000, $200,000 credit for the last 10 years and you've been paying it back religiously every single month on time. Well, they're going to give you credit galore. Is that really a good thing? Probably not. Another company's going to say, you already have too much debt. You already owe $100,000 on your credit card. Why do you want another one? But I've been paying it back consistently. Well, that's where the other company's going to say, well, our rule says this. So then they start giving the rules out. Then you can start playing with the expert system, which is how you get people that go to the emergency room. They say, I'm lightheaded. I can't breathe. My chest hurts. And then they get seen immediately because you're giving them all the signs of a heart attack, or you're giving them all of the signs of a serious condition where they have no choice because you fooled the expert system into believing that you're a critical case, you're first in line. And unfortunately, those people behind you who might actually have those real problems are waiting for you to get seen first. So it's not kind of fair. So companies will be reluctant to give out that kind of information, but people learn it anyway. It's often accomplished by using traces or rules that match the firing order, which is how people figured out, the triage systems. If you're bleeding, don't put a Band-Aid on it. Just bleed on the floor. They'll see you immediately because they don't want you bleeding on the floor. Because there's a contaminant that causes problems for all of the other patients that are in there. However, if you're sneezing, no, that you have the common cold, so you're going to fit into another category. So the rules themselves can be mapped to and/or different types of decision trees, essentially. So learning the system, answering the questions of the system can help you understand what's going on with this. Here's another example of it. The goal is to acquire a TV set. You could steal one, or you could buy one. If you're going to buy one, you can get a job and earn money, hopefully, in combination. Or you could just earn the money. So if you saw this here and you didn't know anything about buying TV sets, you were a 5-year-old and you wanted to buy a TV set, and you looked at the rule base here. If you stole the money, if you got the money somehow, then you could buy the TV set. This is how people think, actually. So that's why criminals aren't necessarily the most intelligent people. in the population. They're usually the most stupid people in the population because they see the rule set and they go, but what? All I need is money. Where am I getting money? Or you could just steal the TV set. That's the other choice. This is a shorter path, actually. But the risk reward is, there's a lot of risk for that. This has got, less risk because you can kind of go through the buy TV routes. But you don't have to get a job and earn money. You can just steal the money and then buy the TV with it. So, which is, the reasoning that a less intelligent person would go through the rule system and break the rules somehow so that they can get seen by the doctor first, or they can own the TV without actually having to get a job. So the explanations to answer a how question, you can identify the immediate sub-goals of the goal in the question and then report them. You can also answer the why question by identifying super goals for a given goal and then report them. Meaning, I'm a student and I want to get a good grade in the class, so I have to pass the midterm, and that could be a sub-goal. So if I pass the midterm, then I'm on my way. So you can just fail everything. Actually, students do this too. I'm sure you guys do. You look at the point values of certain things. If I had a choice, I want to pass the class, but I don't want to do any work, and I just want to pass the class. Well, I have to get a good grade here, and I have to get a good grade here. That other stuff, you know what? I don't want to do that stuff. I'm not going to turn that stuff in. So then you maximize the goal by looking at it, the expert system. And what is the expert system? It's the combination. Is it really an expert system? Not really. It's a mathematical calculation. So, year-to-date sales, is that not necessarily an expert system coming up with that. It's a calculation. Disadvantages of the rule-based systems. Rule-based systems do not learn. There's no learning. In fact, the information might become very outdated, as in the credit card reporting companies, very outdated stuff. They don't use multiple level reasoning systems either. They have one reason why you have food poisoning is because you ate at Mr. Chow's. But what if a new case came up? What if it was Mr. Cho's, the Nut Chow's or something, or I don't know, some neighborhood place, and then now you had the first case. It's not going to learn that. It's not going to know about that. It's going to rule you out completely, perhaps. It also uses constraint exposing models where you actually have to give away your model in order for anyone to understand what it's doing. So if you talk about, food poisoning, you have to tell people, well, it's your stomach. This is a symptom. Actually, it really is not. E. coli poisoning is not even your stomach, but yeah. You have to look at the problem from multiple different perspectives, which an expert system doesn't do, which is why you have 3 different reporting companies. So the loan officer will come back and say, well, let's try it again. It's kind of like inspection companies. If you've ever had get an inspection on something, or if you've ever gotten a quote, you can go to 3 different auto mechanics and get 3 different quotes with 3 different dollar values and 3 different problems that are wrong with your car. And then decide, why are you doing that? Well, because the expert system that they're using to diagnose your car is different. It's working on a different rule-based system. It's not as reliable. Like, you get this with doctors too, actually. Humans make the same mistakes as the expert system because the expert system was created by the human, so it's almost as good as the human is. There's no right or wrong answer sometimes, especially when it comes to the mystery of medicine. So, know when to break their own rules. They don't know when to break their own rules. Just like the person who comes in and says, well, you've eaten at Mr. Chow's, but your arm hurts. You'd have to break that rule and say, you know what, I asked you the wrong question. Sorry, I didn't mean to ask you about eating. Maybe I should have asked you about stretching or moving or falling. Then I would have heard about your arm. But the expert system doesn't know that because it's not reasoning. And then they also do not make use of efficient matching strategies. They don't see the patterns. They don't see any patterns, actually. You'll see the pattern. So a human taking a test versus a machine taking a test, you have instinct. You see something and it says no, 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 yes. There's only one yes option, and the rest of them are no. So, most likely it's that yes. Or, what about that all of the above? So you'll have different strategies in terms of patterns. In the synthesis systems themselves, you're trying to derive something out of it. And so you have a tendency to use forward chaining, often data-driven, often makes use of the breadth-first search, which is not very efficient. So it has a tendency to look at all facts before proceeding. So this is kind of the nature of most expert systems. You have to evaluate a lot of facts before you're going to proceed through it. An analysis system is another name for the diagnostic system that I was describing. The computer is going to analyze your situation to determine how critical you are. It's commonly used for diagnostic problems, classification problems. Tends to use backward chaining, often goal-driven, often depth-first search, and tends to focus on one hypothesis or one path at a time. Easier for humans to follow. In fact, we do the same thing. Our expert system in our brains, we follow one instinct. Oh, it's wrong. I know that guy lied. I know that guy lied. So you find how the guy lied instead of determining outside of that one path. So good thinkers can think in multiple paths. They go, I know he lied. And then they can, well, what if he's not lying? What if he's telling the truth? And that person over there lied. But if you're stuck, it's kind of like what police behavior does. We're on one path, we have a suspect. And then they think, oh, the suspect, he did it, he did it, he did it, he did it. And then everybody else is around them and, I did it, I did it. But they can't see the I did it's because they're focused on one path. Well, expert systems have a tendency to do that as well, actually. You go down a path and you can't get out of it. So that's why learning systems are a little bit better, because the learning systems can profile better and pick better paths, essentially. All right, so the rest of the slide here, I'm actually kind of wrapping this up, believe it or not. So the analysis system and the synthesis systems are two separate types of analysis that can be performed. Backward chaining is in pseudocode here. If you haven't seen pseudocode yet, this is, given the goal G as input, find something, loop, else, and then financial expert systems would use mostly rule-based. These are all rule-based systems, by the way. So you can say expert system, rule-based system is pretty much the same concept. Here's a financial expert pseudocode describing rule number 1, rule number 2, rule number 3. So you're going to come up with a bunch of rules, and you're going to come up with a bunch of facts that you're going to base the rules on. One fact might be savings is equal to $50,000. So the person has $50,000 in savings, okay, and they're employed. And short-term interest rate is down. So, and receiving Social Security, they're also receiving Social Security benefits. Well, that might tell us that they're old, which is kind of interesting because they're not, they're allowed to ask you for your age, and they can use age as a determinant. If you're 70 years old and you're extremely in debt, but you have really good credit history, which means you've been paying back the debt, and you want to borrow for another 30 years, you're not going to live till 100. So you're going to get declined on that loan because of your age. And especially if you're receiving Social Security benefits, you've already retired, which means you're not going to pay that loan back. So we're not going to give you the money. Even though you have perfect credit history and you own, let's say, 3 or 4 houses paid for outright, they're still not going to give you that loan, which is kind of weird. So it's a bias that's put in the fact-based system that says, hey, you're not creditworthy. And it's not because you're not creditworthy, it's because you're going to die before we're going to get our money back. And we have to worry about collecting it in the end. So now there's strategies for that. So they give you the credit, but they'll get it from your inheritance. So they'll get their loan paid back. So, or let's say, for example, the Fed is decreasing reserve requirements. Then you're going to use that as a factor, which is sort of like what happened with the whole, home loan stuff. They said, oh, okay, well, interest rates are at an all-time low right now, so we're going to fix you in for the first 2 years at this really low rate because we know you're going to be able to pay it, right? But you're really borrowing more than we should give you. So in another 3 years from now, we're going to double your interest rate. We're going to double your loan amount. You're probably going to default, but we're going to take your house back and we're going to sell it to somebody else who can't afford it. In the meantime, because the market's so slow right now, we're going to take half of your money right now. We're going to take some of your money. So the strategy basically was pretty good, actually, because a lot of people got to buy houses and they got to go into houses. But they really bought something that wasn't something that they could afford. And the credit card companies knew that. I mean, the financial institutions know that ahead of time, but they're fixing it so you can do it because they want to sell houses and they want to give out loans because they have money to spend and the interest rates are really low. So they put all the money out there, and some of you, a good percentage of you, are going to struggle, get 5 jobs, get your family relatives to help you out, and you're not going to need to be bailed out. So they're betting and they're gambling on your ability to make it work because you own the home, right? It's like when people buy something, they don't want to give it up, right? It's my house, it's my home, right? It's my American dream kind of thing, right? you're not going to give it up. So you're going to do everything you can. You're going to put every last, you're not going to eat. Instead, you're going to make your mortgage payment, right? Because that's what they're gambling on. So that's why the government came and bailed them out, because, you know, it's not fair. Not fair to the consumer. But, oh, come on. The consumer doesn't realize they're buying something they can't afford. So anyway, that was kind of like maybe about 5 years ago at this point. The recent experiences with financial institutions and home loans. But anyway, as an example here, not to go back, but in terms of a financial expert system, we would come up with a fact base, we come up with a rule base, we apply a forward chaining or a backward chaining. Using forward chaining, we would go through a bunch of rules that would fire that says, you know, if this, then that, if this, then that. If we used a backward chaining approach, which is how we do car loans as an example, we would say, is the person the person is creditworthy, and then backwards would prove it right or wrong. And the system, in fact, this is what Prolog does. And it says, you know, this person is a sister. Comes back and says, yes, no, that's backward chaining. So forward chaining comes back and says, is this person creditworthy? And you come back and say, yes, he is creditworthy, or no, he isn't creditworthy. Backward says, he's creditworthy, or he's not creditworthy. Prove me correct. So if I say he's not creditworthy, and it comes back and says no, that means he is creditworthy, or the opposite. So it depends on the logic and what you're trying to solve, if you're going to take a backward or forward approach to the problem solving, but expert systems do both. So in a car loan, they're going to say, you got the car loan. They'll always tell you you have a car loan because you do. The question is, which loan company is going to give you that loan? And how high is your interest rate going to be? Because it's going to come back and say, yes, you got a car loan. And then it's going to come, and then the company is going to find you a car loan that's going to match. So that's the game they play with car loans. So you may end up paying 2 or 3 times what you expected to pay for that because you don't have a car loan. But they're going to make you have a car loan by paying off the company who's going to loan you that money by giving you this extremely high interest rate along with extra requirements. You have to buy this, you have to buy this, you have to buy this. Oh yes, and by the way, the loan cost you $2,000 as well. Because we had to bribe the financial company to give you this loan because you're not creditworthy, which is the games they play in the car industry. But anyway, long story short, you'll always get a car loan because they assume you're creditworthy. So even if you have bad credit, you can come down to this company. They're going to give you a car loan because they're doing backward chaining. They're going to find a poor sucker who is willing to take anything because they want the car loan, which plays off of emotions as well. So, all right, so using backward and using forward chaining and a goal. Here's a goal tree that kind of puts it together. So we have the plan, we have the risk, and here we have the 6-month interest, short-term, Fed's move, all the things that could happen along with all of the decisions that could be made in terms of determining how much interest rate should we charge, how long should we loan the money for, which is what financial companies do for the most part. We can do it in an inference network. I'm going to talk about networks probably after lunch, if not today, tomorrow. We'll hit neural networks and network concepts. We also have deductive systems. By definition, the rules in the expert system can be matched using forward and backward chaining, which gives us by default a deductive system where we deduce a conclusion to something based upon the rules, which is this definition. So sometimes it's desirable to alternate the forward and backward chaining strategies in the same system, which is, you know, if, for example, you're using the car loan example, if we go forward, we could say, well, how much do you make, and to determine, are you creditworthy? And then if you are creditworthy, then if we use a forward, we can say, well, you're creditworthy up to this dollar amount. And then you could buy a car under that dollar amount. So instead, the consumer comes in and picks the car out, whatever dollar amounts. And it says, you're creditworthy. And it goes backwards and tries to find someone to make you creditworthy. Which ends up costing the consumer too much. So if they switch the system around, which some companies are actually doing now, switch it around to say you're creditworthy up to this amount, and then they make from forward to the purchase, they work it out so it's within the benefit of the creditworthiness, versus we're going to get you into this car, we're going to get you into this house, and then make you creditworthy by having you abide by all these different, oh, you have to put so much down, oh, and you have to do this, and you have to do that. Oh, by the way, your interest rate is going to be double what it is for this guy over here to make you creditworthy. So both strategies have pros and cons to them. The systems are designed sometimes using both. They'll go forward and back. Actually, the housing, financial mortgage companies, financial brokers will do that for you. They'll do it for you with life insurance. They'll do it for you with savings accounts, with retirement accounts. You say, well, to go backward chaining, example of that one would be, when I retire at the age of 65, I want to have $2 million in the bank. Okay, customer, that means you have to save $2,000 a month right now. Oh, that's a backward chaining, because in order to get $2,000 then, which is the goal, in order to prove that correct, in order to make that a reality, you have to save $2,000 a month. Instead, you have the approach, well, if I save $2,000 a month, or actually $1,000 a month, let's say for right now, when I'm at turn 65, how big will my retirement be? And the broker will come back and say, well, it'll be $1,000, or it'll be, $1 million or something. So that's a forward chaining versus a backward. So if you start at the conclusion and you work to make it happen, or prove it right or wrong, it's backwards. If you start with, this is what I want, how do I make it work? Then you're going forward. So we actually do both in our lives, and thinking expert systems will do both as well. They'll think about it from both directions. So combined inference strategies here, repeat, look at something, add more information to it. So there's another software package, a freeware expert systems shell that was written in Pascal called EASL, EZI, I think it's called. I don't know if it's still around. There's Python used sometimes for this because it's using search strategies. List processing, functional programs, Prolog, logic-based programs, all have a rule-based kind of system to them. You're doing an expert system with your family tree with Prolog, actually. You have designed, if you did assignment number 4, you have designed a database and you asked it questions. You've already done an expert system, hopefully. And the next one you'll be doing in assignment 5 is the risk assessment that's associated with that. Or, excuse me, the list that's using an expert system. So expert systems can use rules, most of them do. You can also use list processing and trees and neural networks with systems to combine techniques to make the results more efficient. So EZI is also a rule-based system. I'm not going to go through it, I'm just going to introduce it to you as a concept. And EZI does backward chaining. There's also this thing that was called VP expert rules, which was a, should we buy, should we sell? And you think about expert systems, and you get them with information systems, going back to that concept. The CEO has these systems, hopefully, that says, I'm the CEO of Starbucks, and I want to know how many stores do I need to close, because I'm not making my numbers right now. Or what city doesn't have a store in it, or what city would benefit or profit more if I put a store in it. And you're getting one answer out of it, but you're asking it a bunch of questions, and it's using all sorts of different data out there. It's using population growth, it's using household income, it's using statistics and demographics and stuff. It says, well, all your coffee drinkers, they live in Santa Cruz. Oh, all right, maybe I should have one in Santa Cruz, based upon the data. And so you have informal and you have formal expert systems, and some that just use logic. So this is another one. The VP expert system is another one. So we're going to break now for lunch, so I'm going to stop this video. So we're going to look at knowledge acquisition next after lunch. We'll have some time to work on assignments as well. But I'm going to break now, break this video.